Assalamu alaikum students. Today we are going to start lecture number 5, okay, where we stopped in the last lecture. We have looked into the network core devices, and we looked into the switching techniques, circuit switching, packet switching, and the network infrastructure from the switching point of view. Today we will start looking into the different type of delays, loss, packet loss, and throughput in the packet switched network. How the loss and the delay occur on the packet switched network. This is the topic we have to look into it. We have studied then the packets when these are arriving from different computers onto the router. The router will store the packets into some temporary buffer. Okay, why? To process the packets. Otherwise, if the input rate will not cope with the output rate, if it is more than that and there is no some temporary storage buffer area in which the router can store the packet will start dropping. Even though it will drop sometimes, but due to congestion or some other reasons. Okay, but in order to store the packets on the router does need some temporary location which is called the buffer, and that it will keep on storing the packets unless until the packets are processed by the router. So these are called the packet. This is called the packet queue in the router buffer, where the router will store the packet which are coming from the input ports. Okay. So packet arrival rate to link exceeds output link capacity. What will happen in that case? Okay, packet arrival rate, if it exceeds output link capacity, then definitely to some extent these will be storing in the queue, and after that they will start dropping. They will be dropped. Okay. Now when they are being stored in the queue, they have to look that if there is a free space available in the buffer, they can be stored in the buffer in the queue. But if there is no free slot available in the buffer, definitely they will not get space and they will be dropped. Okay. So packet queue, in the packet queue, the packet will wait for their turn to come, and the packet will start transmitting on the transmission link. Okay. So all the packets will be waiting in the queue for their turn to come, and their transmission starts over the output port on the transmission link. Now packet being transmitted on the transmission link, definitely it will be having some delay over there. What will be that delay? It depends on the number of the bits in the file and the bandwidth of the link on which it is going to be transmitted. Okay. So this is the first packet which is picked from the head of the queue, and its transmission is started over the transmission link. These are the other packets which are being queued in the packet queue. Okay, and definitely they are waiting for their turn to come. So they are waiting in the queue for their turn to come, and their transmission begins to start their transmission. Okay, they are waiting in the queue. So this is the waiting time in the queue. So definitely it will be accounted for in terms of some delay there. Now you have to look that are there free buffers available. So these white are the free buffers available in the queue. So free available buffers. Okay, and the arriving packets will be stored on these free available buffers if they are coming from the input link. But if the free available buffers are not there, there is no free available buffer or available space in the queue, what will happen? The packets arriving on the input port will start dropping. Okay, so they will be dropped, and this will be a loss. if there is no free buffer space available in the queue. Now we have 4 different type of delays here. 4 sources of packet delays are there on our router. Okay, what are these? We will study one by one. First one is the noodle processing delay. Noodle processing, the time the node will take to process the packet. It is called noodle. From node it is noodle processing delay. Okay, it will check the bit errors. Definitely the packet which is being received on the node will process this packet and it will check definitely the bit errors, and it will determine if there are multiple output links on the router. It will determine that on which output link the packet should be sent, the packet should be transmitted. Okay, it has to determine the output link by looking into the destination address in the IP packet header and comparing it into its routing table, that this particular network can be reached through which output port. Okay, so this is called the noodle processing delay, the time the router will take to process the packet on that particular node. That node is basically that particular router. And the second is the queuing delay. This is the queuing delay which the packet will take in the queue. If there are 2 packets right now in the queue, this packet is on the propagation towards its destination. This packet's transmission is going to be started, and these 2 packets are right now in the queue. So they are waiting in the queue. So they are facing the queuing delay, and this packet is going to be transmitted on the link. It will face the transmission delay, and the packet whose transmission has already been started and it is on its way towards its destination, it will take definitely some time to reach onto its destination. It means it is on the propagation towards its destination. That is why it is called propagation delay. So the second type of delay, which is called the queuing delay, it is a time a packet will take waiting at the output link for the transmission, for its transmission to begin, to start. And it depends on the congestion level of the router, that how much congested the router is. Okay, how much packets are ahead of this packet in the queue. Okay, the third type of the delay is the transmission delay. This delay, okay, the packet is facing, and this transmission delay depends on the R, which is the link bandwidth. Definitely it is measured in bits per second, and L is the packet length, how many bits are there in the packet. And this time, transmission delay, is a time which is required to send bits into link. Okay, and it is equivalent to the number of bits in the packet, the length of the packet divided by the link bandwidth in bits per second. Okay, this we have done this numerical already, and so we are familiar about the transmission delay. The fourth type of delay is the propagation delay. Propagation means if I am throwing a ball to you, and the propagation delay starts when the ball starts its journey left my hand, and unless until it is catched by you. So the time it took while it started its journey and it reached to the destination. So this is the time which it took for its traveling from source to the destination, when its journey is started and when it is going to be end. So this is called the propagation delay. Okay, D is equal to the length of the physical link. So definitely if the length of the physical link is very long, so should the propagation delay be more in that case? No? Yes, definitely yes. It depends on the length of the physical link, how long it is. S is equal to the propagation speed in the medium. So usually it is approximately equivalent to the speed of light, 2 into 10 raised to the power 8 meters per second. and propagation delay will be counted as d, the length of the physical link divided by the speed. Okay, distance divided by the speed. Okay, length means distance. Okay, note S and R. This S, which is the propagation speed, and R are very different quantities. This is the link bandwidth and this is the propagation speed. So propagation speed and bandwidth both are the different quantities, not the same. Speed means how fast it is traveling, and bandwidth is how much space it is getting on the pipe to travel. As far as we have more space, more data can travel. If we have less space, the width of the band, if it is narrow, there is less space to the water to flow. Take an example of a water pipe. If the diameter of the water pipe is more water can flow. If the diameter of the pipe is narrow, less water can flow through the pipe. Speed is different. Speed depends on the motor, pump, how fast it is pumping water into the pipe. Clear? And how bigger is the pipe, that is bandwidth. How powerful is the pump to pump the water in the pipe, this is the speed. The speed depends on the pumping power of the motor. Clear? These are two different quantities. It should be clear in your mind. Don't confuse the speed with the bandwidth, okay? Clear, boys?
What's the difference between transmission and...
Yeah, transmission mean the link bandwidth, how wider it is, and the packet length, how long is the packet. Okay, it depends on that. Okay, let's take an example, caravan analogy. For example, we have a tool booth, the checkpost from where the cars enter on the highway, on the motorway. 10 car caravan, it is going to be entered on the highway through the tool booth. Okay, cars are going to propagate at 100 kilometers per hour. So what is this 100 kilometer per hour? It is the speed of the car. Tool booth, the checkpost, tool booth, it will take 12 seconds to service the car, the transmission time. This is the transmission time. How long it take the booth to process a car. For example, the car comes to the booth. The computer operator will enter its number, or it will be sensed by some sensor, and its number will be entered into the computer, and then the computer will issue it a card or a ticket. It will take the ticket and starts its journey. So this is the time of the transmission. Clear? Car, consider that car is like a bit. So here we have 10 cars, mean for example we have 10 bits here. Okay? Caravan is equal to a packet. So it's mean in the caravan if there are 10 cars, it's mean assume it that in a packet there are 10 bits, for example. Clear? This is an example. How long until caravan is lined up before second tool booth? This is the first tool booth. This is the second tool booth. The distance between the two tool booths is 100 kilometer distant apart. Okay, so it is asking that if 10 cars are lined up here, okay, every car will take 12 seconds for its transmission processing and to begin its propagation, its journey, and the distance between the first and the second tool booth is 100 kilometer. How long it will take that all the 10 cars will be, is how long until caravan is lined up in front of the second tool booth, before the second tool booth. Caravan mean all the 10 cars should be lined up here on the second tool booth, as they are 10 cars are lined up here at the front tool booth. Clear? So time to push entire caravan through the tool booth onto the highway is equivalent to how many cars are there? 10. How many time one car's transmission will take? 12 seconds. So 12 into 10 cars, 12 seconds into 10 car is equal to 120 seconds will be taken by the tool booth, first tool booth to process all the 10 cars, okay, mean to transmit the 10 cars on the highway. Clear? Now they have started their journey, for example, and the cars are moving on 100 km per hour speed, and the distance between the two tool booths is 100 km. Time for the last car to propagate from first tool booth to the second tool booth is equivalent to 100 is the distance, d upon s. Clear? We looked into it. D upon s, propagation delay. We are going to count, we are going to calculate this delay. So the time for the last car to propagate from first tool booth to second tool booth is the distance between the two tool booths, which is 100 km, divided by 100 km per hour, which is the speed of the car. Clear? Is equivalent to 1 hour. 1 hour. Okay. So approximately 1 hour plus 120 seconds. 120 seconds mean how many minutes? 2 minutes. So 1 hour is having how many minutes? 60 plus 2, how many minutes? 62 minutes. It will be taken. Clear? This is more. The same example is being repeated, but with some changes. Cars now propagate at a speed of 1000 km per hour. It is not possible for the car of 1000, but let's take an example. Okay, is there any car with the speed of 1000 km, by the way? No? No, Bugatti. Not 1000. Okay, no problem. Let it be 800. Okay, 1000 km per hour is the propagation speed for the cars now. For example, okay, tool booth now takes 1 minute. Before it was taking 12 seconds for one car. Now it is taking 1 minute to service a car for its transmission. Okay, will cars arrive to second tool booth before all cars serviced at first tool booth? Now you look into it. Their speeds are very fast and their processing time for the transmission is very slow. Slow mean taking more time. It will take more time. Speed is very fast. Booth is taking too much time to process the car. Okay. Yes. Will car arrive to the second tool booth before all the cars are serviced at the first tool booth? Yes. After 7 minutes, first car at second tool booth and 3 cars still at the first tool booth. Because 7 minutes mean 7 cars have been processed in 7 minutes. Okay. So after 7 minutes, first car will be at the second tool booth and 3 cars are still at the first tool booth, which needs to be processed. First bit of the packet can arrive at second router. First bit can arrive at the second router before the packet is fully transmitted at the first router. Still, so 10 cars mean 10 cars are there in the caravan mean 10 bits are there in the packet. First bit of the packet has arrived on the second router. Still 3 bits are being processed on the first router. Clear? Transmitted at the first router. See Ethernet applet at AWL website. You check on your book website. The applet. This applet will explain this analogy. Okay. Now the noodle delay, the D noodle, the total delay at the node is equivalent to the processing delay plus queuing delay plus transmission delay plus propagation delay. How many types of delay we studied? Delays. 4 types of delays we have studied in our lecture today. One is the processing delay, which the node will take to process the packet. Second is the queuing delay, the delay which the packet will face by waiting in the queue unless until it is going to be its processing starts. Okay. Third type of the delay is the transmission delay. How long it will take to process the packet to starts its propagation. Okay, unless until it is took from the queue head and it is being processed, everything is being checked, its destination IP address is being checked, bit error rate is checked, and it is sent out on the output port. This is the transmission delay. It depends on the size of the packet and the bandwidth. Okay, propagation delay, how long it will take the packet to start its journey, the bit to start its journey and to reach its destination. Clear? Processing delay, typically a few microseconds or less than that. Queuing delay, it depends on the congestion, that how many packets are there in the queue. Okay, how many traffic is there in the queue. Okay, transmission delay depends on the size of the packet divided by the bandwidth, significant for low speed link. So if the speed of the link is low, it's mean it is significant in that case. Definitely, if the packet size is bigger and the speed of the link is slow, so definitely it will take more transmission time to transmit the packet. Propagation delay, a few microseconds to hundred of milliseconds. It depends from micro to milliseconds. It varies starting from microseconds and it could go till milliseconds. Clear? Queuing delay, we will have a look into it. Queuing delay inside the queue. Average queuing delay, and this is the this graph depicts the traffic intensity on this side on the x-axis, and on the y-axis it is showing the average queuing delay. R is the link bandwidth, definitely it is in bits per second, and L is the packet length in the bits, and A is the average packet arrival rate in average, okay, for the packets. So traffic intensity, it depends on length of the packet multiplied by its average arrival rate divided by the link bandwidth. Not only the length, okay, it depends on the length, but intensity depends on the arrival rate, average arrival rate, that or with which rate the packets are arriving on the router. If this quantity, if this product is more bigger, so the traffic intensity is its mean more. Okay, in order to reduce the queuing delay, the bandwidth should be less or more? More. If the denominator is bigger, it would be divided with the bigger, so the answer will be, it is inversely proportional. If it is increasing, to control it, to process it, this should be increased, so that the traffic intensity could be handled more easily. Clear? So this traffic intensity, if it is approximately 0, average queuing delay is small. Okay, if it is approaching to 1, its mean delay becomes larger. If traffic intensity is approaching to 1, this is traffic intensity. If it is approaching to 1, its mean the delay is, if it is 0, okay, no problem, but if it is approaching to 1, its mean average queuing delay will start increasing. And if it is greater than 1, if this value is greater than 1, it exceeds the boundary of 1, then what will happen? More work arriving, more traffic is arriving than can be serviced or processed by the router by its capacity. So average delay will become infinite for the packets. Real internet delays and routes, okay, on the internet, how it is being handled. What do real internet delay and loss look like on the internet? we have some commands over the net to be used over the network in order to look into the delays. For example, trace route command here, it provides delay to us, delay measurement. We can measure the delay with the help of trace route command. This command you can give on the packet tracer, and it will measure your delay from source to router along end to end internet path towards the destination. It will calculate your delay towards the destination, but it will not calculate it directly. It will calculate hop by hop. For example, if this is your source, this is your destination, how many hops are there in between? 5 routers are there in between the source and the destination. So in order to calculate the delay from source to destination, definitely it has to pass through different 5 nodes. So every node will have how many types of delays? 4 types of delays. So the whole delay will be majmua of, will be sum of all the delays on all these intermediate nodes, because these are the intermediate hops coming in between. Can you send a packet from here to directly Hotmail? No. It has to go through the intermediate hops. Clear? Is it clear to you, boys?
All router have
Yeah, like this, the example we studied, that every router will be facing 4 different type of delays.
equal delay.
It depends on the traffic on the router. It couldn't be equal, because there are other links on the router as well. It depends on the traffic condition, traffic intensity. That is why we studied the traffic intensity here, because queuing delay is dependent on the traffic intensity. Clear? So send 3 packets that will reach the router I on the path towards its destination. Router I will return packet to the sender, return packet to the sender back, because here we are measuring till router I, the delay till router I. Sender times interval between transmission and getting its reply back. Okay. 3 probes. It is probing 3 times to the first router from source. Then 3 probes are sent to the second router. Then 3 probes to the third router. Okay. Look here. It is going and coming back. Going and coming back. Going and coming back. Okay. For example, if we look into this example, trace route gaia.csumass.edu to www.yercom.france, 3 delays measurement from this website to this. Okay, and these are 1 millisecond, 1 millisecond, 2 millisecond. 3 times it is sending the packet and measuring the delay. So from every router, look here, it starts from here and it goes till here. Okay, till here. And these are the intermediate hops in between from where the packets are passing. And on every node, intermediate node, it is probing how many times? 3 times it is checking the delays. Okay. Here, if the stars are coming, it's mean no response. Probes are lost. Router not replying. Okay. It could be due to firewall or due to your ping is blocked, because traceroute basically uses the ping command to transmit the packets to check the delay, and ultimately this is the final. And this is the majmua of, this is the sum of all these. Got it? The first one with all the first one will be summed up. The second one is the total of all the second probes, and the third one is the total of all the third probes. Clear? And by taking their average, definitely. Yes. Dividing by the number of nodes. Clear?
Yes.
We can try this example. go on the command prompt. Okay. Now there are two different type of trace route and trace cert. Okay. Here on the Windows operating system, trace cert will work, but on the Linux and the routers and the switches iOS, trace route will work. If you give here trace route command, it will not work. Trace route, okay, for example www.google.com, it will not work. Okay, you have to give here trace cert www.google.com. okay, now it will start working. Look here, it is probing how many times? 3 times. 3 times. Okay, 1 2 3. This is the first starting, okay, from your computer. Look here, the IP of your computer. (10.6.73.200). This is your gateway. It is starting from your gateway, because your gateway is the first hope. This is your source computer. You are miring from here. The first hope will be your Jamia router. Clear? So 73.1. Look here for 73.1. This is 73.1, your Jamia router, and then it is going to be, it could be your Jamia router, or it could be the first hope for this source host, and then the second one, third one, fourth one, and it is going, ultimately it will reach. Till now it has gone through 15 hopes, okay, and where it has to go? From our computer to google.com. Okay, let it complete. Trace complete 17. So ultimately it reached here. Look here, this is the last hope. So these are the delay: 121 millisecond, 122 millisecond, 121 millisecond. So average is 121 millisecond it took. So we said in our lecture, it starts from microsecond to, it starts from microsecond to millisecond, few microsecond to millisecond. So it is measured in the milliseconds. Clear? Is it clear, guys? The example is clear to you? Have you seen practically with your own eyes? Good. Now when the packet will start, when the router will start losing the packets. Can you see on the buffer right now? What is the status of the buffer on the router now? Is it full? Yes. What will happen if the packet will arrive from the input queue now? Delay mean, who told delay? If it will enter the queue, then it will start facing the delays. If it will not enter the space, if it will not get the space to enter into the queue, it will be dropped. So there is no question of delay right now here. Queue, also known as buffer, preceding link in the buffer has finite capacity. There is finite capacity. Remember, these buffers are of finite capacity. Packets are arriving to a queue which is already full, and the packet will be dropped definitely. It is also known as packet loss. So lost packet has to be retransmitted by the previous node again. If it is lost, it means it is not received at the destination. If it is not received at the destination, it means it has to be retransmitted by the source host. Is it clear? It is dropped on the router. Why? Because the buffer was full. If it is dropped, it means the destination has not received, the packet has not reached to the destination host. It means it has to be retransmitted from the source host again. Clear? It has to be retransmitted by the source end system again. Clear? So the buffer is the waiting area. If it is full, the new coming packet arriving to this full buffer will be lost, and from the head of the queue, the new packet will be arriving at the tail of the buffer, will be lost if the buffer is full, and the packets will be transmitted will be taken for the transmission from the head of the queue. Clear? what is the throughput? Throughput. If this is a pipe, if you cut the pipe from here, this is the diameter of the pipe, for example, you cut it from here. You want to check that in unit time, that unit can be 1 second, 1 minute, 1 hour, how many gallons of water is flowing from this particular point. This is called the throughput. Clear? Throughput means the rate, number of bits transmitted in unit time. This is the rate. We call it data rate. What is the data rate? What is the rate of flow of water at this point? Okay, this is the throughput. The rate, number of bits in unit time at which bits are transmitted between the sender and the receiver. Clear? Instantaneous rate and the average rate. Instantaneous rate at a given point in time, and average rate is the rate over longer period of time. You have taken so many instantaneous rates at given points in the time. For example, you have different instantaneous rates, but you want the average throughput, so you can call it the average rate. Add all the instantaneous rates and divide it with the number of the times you have taken the instantaneous throughput. It will give you the average throughput. Clear? So this is the server, okay, with file of f bits, and it is sent to the client, and the link capacity is Rs bit per second. This is the router, and this is another link capacity, RC bits per second. So its capacity is RS bits per second, and its capacity is RC bits per second. This is the server, this is the client, this is the router. It is hidden behind this arrow. Okay, this is one link from server to router. This is another link from router to the client. So these are two different links. Clear? Now, what is this? This is the pipe, okay, that can carry the fluid at rate. This is a link. In terms of link, we call it either copper link or optical fiber link or wireless link. So assume it or try to understand it with the analogy of pipe through which the water is flowing. For example, okay, this is a pipe that can carry fluid at a rate of Rs bits per second, and this is a pipe. Can you see this pipe? Is this pipe bigger than this?
Yes.
It's mean its bandwidth is bigger or its is bigger? Whose diameter is more? The next one. It's mean it can carry more fluid? Yes. Pipe that can carry fluid at a rate of RC bits per second. Server sends bits fluid into the pipe, so the server is working like a pump. It is inputting the water, injecting the water into the pipe. Clear? Pipe that can carry fluid at this rate, and this pipe can carry fluid at this rate. Okay. Now, look here. Can you look here that the rate of the first pipe, is it less than or bigger than the rate of the second pipe? Less than. Why? Because its diameter is smaller as compared to the second link. So what is average end-to-end throughput? Because end-to-end will be measured from here to here, from server to the client. In between, two links are having different rates. Their bandwidths are different. So definitely their throughput will be, instantaneous throughputs will be different. But when you take the average, it will be different. Clear? So what is the average? We are asking about the average, not the instantaneous. We studied two types of rates. Instantaneous at given point at any time an average rate over longer period of time from source till destination. Okay. If this is more bigger than this one, what is the average end-to-end throughput? In case if RS bits per second rate is more of this link as compared to the second link, in that case what it will be. So where is the bottleneck? In bottleneck, where is the problem? Where the problem can come in both the scenarios, link on end-to-end path that contains end-to-end throughput. If you are measuring end-to-end throughput, okay, now look here, the capacity or the rate of the first link, if the file is going from server to the client, okay, its capacity is less as compared to its. It means there are less chances on the router of congestion because it is water is coming at less rate as compared to the water leaving from the router. But if water is coming at a more rate as compared to the water leaving the router on a less rate, so in which case there is a chances of congestion on the router, in this case or in this case? In the second case, because the input is more as compared to the output capacity of the router. This router, actually the router is hidden behind the arrow. Is it clear? Is it clear? Look here. This, yeah. Is it clear now? I think you will think that what is this? This is just an arrow. This is not an arrow. This is the router actually. Now it is clear? So, link on end-to-end path that constrains end-to-end throughput. Now, if you are measuring end-to-end throughput, you have to consider both the links throughput in mind. Okay, clear? Where are more chances of congestion on the router, in this or in this? So it means you are inputting more than the capacity, output capacity of the router. It means in this case there are more chances of congestion on the router as compared to this one. So this is more better as compared to this one. Okay. Yeah. Okay, we will stop here. Inshallah, we will continue from here in the next lecture.